welcome to the Luminar Inventors, the podcast where we embark on a journey through the time to explore the transitions from geocentric model to the revolutionary heliocentric model of the solar system. Let's start this podcast. Girls, did you know that many years ago people believed that the Earth revolved around the Sun? You have to be crazy to think about that, right?
Oh my god, I'm surprised by the different opinions people hold.
This thought was known as the geocentric theory. This belief was now deeply implanted in ancient Greek philosophy and later adopted by influential figures like Aristotle and Ptolemy. On the other hand, Christianity suggested that God was the one who put the earth in the center of the universe, making it a special place to observe the development of human life. People believe in this because if you stand from the earth, it gives the perspective that the sun and the stars move across the sky. However, the geocentric theory dominated this thought until the early modern age.
I thought that the geocentrism was when people believed that the Earth was flat.
Well, no. It was because people thought that the Earth was the center of the universe.
Oh.
But later, this idea changed and is the one that we know nowadays.
And who will have been the person who created the theory that we all know today?
I just remember my dad telling me about a man who proposed a theory that challenged the one you just mentioned. According to him, this man believed that the sun revolves around the solar system, completely contradicting the previous theory.
I know the name of the mystery man. It's Nicholas Copernicus.
Finally, at least the first thing you know, Luana. Nicholas Copernicus is one of the best known people in the world of astronomy. As Triana's father said, he was the creator of heliocentrism. Nicholas Copernicus made the heliocentric proposal in the year 1543. Initially, there were some problems since the heliocentric was assembled without a telescope, and in this case, they just used other simpler instruments. All the observations were made by sight.
You're right about the theory creator, but actually there were earlier thinkers who proposed similar ideas. Centuries ago, Greek philosophers like Philolaus suggest a different theory about the center of the system. They proposed that the Earth might be revolving around a burning object. Around 2 centuries later, the Greek astronomers Aristarchus of Samos specially identified the sun as the object.
Whoa! Is that possible? I didn't know that.
Me neither.
Also, this heliocentric model solved some problems, such as the retrograde motion and the reliance on circular orbits limited its success in predicting planetary positions. Tycho Brahe and Johannes Kepler make significant advances in support of the heliocentric model. Brahe's precise observations of the planetary positions over many years provided valuable data, and Kepler used this data to propose 3 laws that accurately describe planetary motions. These 3 contributions helped increase the acceptance of the heliocentric model over time.
Wait! Kepler sounds like a dog's name. That's curious since that name sounds familiar to me. Anyways, who is Kepler and what did he do?
Honestly, I'm not so sure exactly what Kepler did, but Luana must know.
Of course I know this topic. I would love to explain it to you. Johannes Kepler was one of the people who helped improve the heliocentric theory. His main contribution was to correctly define the orbits. As a young man, Kepler was an assistant to an astronomer named Tycho Brahe, who made observations that later helped Kepler discover that the orbits of the planets followed 3 laws. First law, the planets move around the sun in elliptical orbits. Second law, planets sweep out in equal areas and time. Third law, the square of the orbital period of a planet is proportional to the cube of its media distance from the sun.
Whoa, I didn't know that. Thanks for sharing this valuable information with us. Now let us return to the subject of heliocentrism. From what I remember, at that time there were not so many tools to introduce this theory. I wonder how they were able to prove this theory even though without a telescope.
The first observations were very complicated, since they didn't have too many tools to discover or get exact results. But the first one were 2. Let's start with the Jupiter's moon. Galileo observed that there were 4 stars surrounding Jupiter and figured out that these stars were actually moons in the orbit of Jupiter. This observation raised doubts about the geocentric model, and Galileo concluded that not everything revolves around the Earth. Any planet which has moons can experience eclipses. This observation raised the question of why celestial bodies would orbit a planet that was not Earth, but Jupiter.
Wait, I want to explain the phases of Venus.
Okay.
The phases of Venus. Galileo used his telescope to show that Venus goes through a complete set of phases, similar to those seen on the Moon. Through his observations, he noted a striking resemblance between the phases of the Moon and Venus. This led him to deduce that a pattern of phases could only occur if Venus orbited both the Earth and the Sun. However, according to the heliocentric model, Venus would perpetually appear as a perfect circle with no perceptible phases. This event, for me, was one of the most interesting and curious.
And when people finally accepted this theory, what were the impacts?
I certainly know this question. With the heliocentric model, which placed the Sun at the center, astronomers could more easily reinterpret observations and explain the motions of the planet. It became evident that the planets, including the Earth, revolved around the Sun in elliptical orbits rather than the previously assumed circular paths. On the other hand, Johannes Kepler's contributions, including his 3 laws of planetary motions, improved our understanding. Kepler's law provided a mathematical description of planetary orbits, allowing more accurate predictions of planetary positions.
And that concludes our journey through the birth of heliocentrism. Can you believe the audacity it took to challenge a long and old beliefs? Mind-blowing, right? I have explored how this revolutionary idea challenged long-held beliefs, controversies, and also the change of understanding of our universe. Heliocentrism helped the way for advancements in astronomy, the development of scientific methods, and a deeper appreciation of our place in cosmos. Join us time for another exciting exploration into the realms of scientific revolutions. Thank you for joining us on the Luminary Inventors. Stay curious, stay comics, and catch on your flip side. See you next time!
Bye!